The broadcast is now starting. All attendees are in listen-only mode. Starting. All attendees are in listen-only mode.
Good evening. Let me just put the volume here. My name is Bashir Fancy. I'm the Vice President of CIPS Ontario, and I'm also the Chairman for CIPS Canada. I am very pleased to welcome all the CIPS members and those attending tonight on this webinar, certainly tonight in Eastern Canada. We're very fortunate that we've got a couple of gentlemen from Argyle, Dr. Ian Howells and Dr. Deanne Milkovich, who are going to speak. So certainly Dr. Ian Howell will start off the presentation, where he will have both the presentation and even show you a live demo of the machine learning and how you fight fraud. Dr. Ian Howell's decorated is an expert globally on this machine learning and big data analytics that we're really talking about here. So we're fortunate to have these two gentlemen who are going to talk to you today. I will let him speak to you because he's got a very, very good track record and background. And he's also the author of the book, Fighting Future Fraud, because we all know that things are changing and getting more and more difficult. So I don't hold up, but I'm very happy in line with what CIPS is all about, Canadian Information Processing Society, to bring this to you. And so without much ado, I'm going to cut out of the picture and let Dr. Ian Howell take over. After the presentation is finished, after an hour, which is 40 minutes and 20 minutes of the actual demo, you will have 30 minutes of Q&A. So we look forward to, bringing something very knowledge-based information to you guys. So Ian and Deanne, welcome this evening, and why don't you take it away from here?
Thank you, Bashir.
Thank you, Bashir.
So, will you hand the presenter control over to me now?
Yep, I will do that if I haven't done this already. Just bear with me, gentlemen. And you are getting it there. Okay, you are in control now, Dr. Howells. So let me stop my camera here. I need to. Okay.
Thank you, Bashir. So, as you said, my name's Ian Howells. My background is I originally did research into distributed database systems, and I've spent most of my life in the, used to be called the very large database space, but now it's called the big data space. And I've really applied this at Argyle Data, really with a combination of people out of the big data space and the machine learning space and the mobile operator space, applying machine learning to discover fraud, particularly new kind of frauds as they're continually changing. And I'll try and make this as educational as possible. I've got with me a colleague who's out of engineering who wrote a lot of the machine learning. Deon, like every true data scientist, has a really hard to pronounce European surname. So he'll be answering questions with me later as well. So I think what I try to make today is to try and make it as entertaining and educational as possible. And we looked at best practice for fraud. And it was kind of interesting when we looked at it, considering it was for the mobile space. And we looked at techniques really pioneered at Facebook and Google and looked at how they can be applied to fraud. We also looked at how graph techniques pioneered at LinkedIn can be applied to crime ring forensics. We looked at, what does a data lake really mean? Why is it? What's different about it? And specifically, what is a CSP or communications server provider data lake? And then what we kind of discovered, we interviewed a large number of people, and we saw nearly everybody has installed Hadoop, particularly in the mobile operator space. But when they've installed Hadoop, it's much more difficult to look at which application do you start your big data journey on. We can look at that kind of process as well. So if you look at the agenda, really I want to go through the shift towards big data and what that means towards applications, because these kind of shifts happen once a decade, and I think it's important to look at the past to predict what's going to happen in the future. Then look at some analysis of the fraud market, look at the traditional approaches to detect fraud, and then look at how we apply machine learning against a data lake, how we can apply graph, And then look at the kind of the underlying data lake expansion, because you can't have a data lake per application. You need one data lake for many applications. We'll go into a live demo and we'll look at some real machine learning and graph. And as Bashir said, we'll then go to live Q&A. So the thing that stuck out for me was I was an employee in the 80s in the relational database space, and it was a fundamentally better way to manage data. You could dynamically run a SQL query instead of waiting 6 months for IT to write you an application, and it just changed the way you manage data. So the 80s was about better ways of managing data in relational databases, with Oracle becoming the market leader. The 90s was really about applications being written on top of relational databases, particularly Oracle. Then you look at the early 2000s. I was in the open source space then, and you saw a shift in the kind of the cost dynamics of the underlying infrastructure to what's called the LAMP stack: Linux, Apache, MySQL, and PHP, and that changed the economics of managing data to enable Google's and Facebook's and Amazon's and Wikipedia to be written. And I think you look at where we are today, we're starting to see Hadoop become a better way to manage very large amounts of data, with Cloudera becoming the Oracle within that space. And then what you're going to see is many, many data-driven applications written on top of Hadoop, just like they were written on top of the LAMP stack and written on top of Oracle. And we're just starting to enter that phase now. So in 5 years' time, there'll be hundreds of applications written on Hadoop. And that's really what we see as the shift that's happening at the moment. So what's kind of interesting, though, is when you look at that shift and you interview people, there are hundreds of applications that can be written. And these are examples of the ones we've seen, but then people look at them around big data and around location, and they almost don't know where to start and don't know if there really are big data applications. So what we believed fundamentally was there's an opportunity to look at dramatically more data across more sources more often. And when you look at that amount of data, it's very tough for human beings to do traditional analytics. So you need a way to look at more data in a more efficient way, which is really machine learning. And then look at graph visualization. And then we believe these applications, just like they were written natively on Oracle, were written natively on the LAMP stack, will be written natively on Hadoop, and they'll analyze the data in real time. So really Hadoop is moving from batch to real time. So we believe big data applications are different, and they exploit the underlying architecture. They're not the kind of thing you run on your laptop. And when you look at some examples at shows of big data applications, some of them aren't really big data applications. We want to have applications that were not possible from either a technical perspective or an economic perspective 5 to 10 years ago. So when we looked at it, we kind of filtered out the systems, and we looked at the best place to start. Now we believe fraud was a very good place to start, specifically around roaming and domestic fraud and dealer and subscription fraud. And the other important thing was it has a really well-defined ROI. So it can fund and justify the start of your big data venture after you've installed Hadoop. And there's a natural extension really going from fraud into dealer fraud. You just add in incremental data. That's what's important about the concept of a data lake, is you move from application to application incrementally by adding in incremental data sources rather than a whole new data source. And then you can move to Customer 360 and IoT analytics, for example. And you think about these new applications. I think one of the critical things about big data and data lakes is you can't have a data lake per application. So if you're going to have a cool application that remembers where you parked your car or where you've lost your keys, you can't have a brand new infrastructure and a brand new data lake for that. It has to sit in the existing data lake. So what's important when you're looking at your data lake big data strategy is to look at applications that share data. So when we look at fraud, that's the reason we looked at fraud. There's a Communications Fraud Control Association does every 2 years analysis on the size of the market, and the communications industry loses about $38 billion per year, about 1.69% of revenue, and this is just an example breakdown. And we did a lot of big data analysis in this to really look at what are the trends and where are the areas to focus on from a big data or machine learning perspective. Some interesting things kind of came up. Is, for example, international revenue share fraud grew by 500%. It's about 10.8 billion of that 38 billion. So that kind of says existing systems are not dealing with that in a particularly good way. You look at subscription fraud or never pay, where people are stealing phones. We'll go into the details of this in a second. It's about 30% of the total. And the way we look at roaming fraud is you think it's a platform. So you have Windows and Mac, and you have iOS and Android, and you have roaming and domestic fraud. And these are just different platforms. So, for example, traditionally people think of you get attacked more on Windows than Mac, or you get attacked more on Android than iOS. And roaming fraud has more attacks and more losses than domestic platforms. So really think about it as a platform. When you look at the areas we saw as kind of the 80-20 rule, is what you can see is if you look at the places where you artificially inflate traffic, either for international revenue share fraud, which is IRSF, domestic revenue share fraud, which is DRSF, or premium rate fraud, that's when you add those together, that can be like 51% of the total market if you add in arbitrage, which is, we believe, often underestimated. And then kind of the new kind of growth area around subscription fraud and dealer fraud. So we believe if you look at the 80-20 rule, doing those well makes a big difference, and be able to do it well on a roaming, but also a domestic platform is important. So that was kind of what was kind of interesting, which is the good news, the bad news was, if you look at fraud, the fraud market is really gone down in 2 years from 46 billion to 38 billion. So you think that was great news. But, you know, we kind of interviewed a lot of people, and obviously the CFCA did as well. The kind of interesting dynamic when you go down from 46 to 38 was 88% of the participants in the same study believed fraud was going up globally. 73% believed it was the same or going up. 73% believed it was the same or going up within their own companies. This doesn't stack up. And it's almost like, are we focusing on the wrong war against fraud? And there's a famous phrase by Donald Rumsfeld about there are known knowns. Those are things that you know. And there are known unknowns, which are kind of things you kind of suspect, but you don't know how to codify. And there are unknown unknowns, which are things you just don't know. And are we focusing on the known knowns? And are the criminals focusing upon the known unknowns and unknown unknowns, which machine learning is very good at detecting, by the way, which we'll see in a second. So really, in conclusion, when we looked at it, most people privately believe fraud isn't really going down and that criminals and state actors are getting better at going undetected. And most people don't believe the mobile world is different to the rest of the world. When you look at this, there were league tables about breaches with Google, JP Morgan Chase. This is something that's happening in every industry. And what we want to look at in this presentation is a way to actually detect known fraud and unknown fraud in a better way, exploiting the latest machine learning techniques. So before we go into mobile fraud, some of you will know it very well in the audience, and some of you won't. So I just want to get everybody on a level playing field to make the demo more entertaining. Just give you a quick crash course in mobile fraud. So when we think about international revenue share fraud, and kind of the mechanics behind this is what you're doing is artificially inflating traffic to a destination. So when you think about it, you can set up a premium rate number in Cuba or Somalia, and if nobody calls those numbers, you make no money. So what you really have to do to inflate the traffic is drive traffic to a number or range of numbers. There are a common couple of ways to do that. One is called robodialing, and it has a cool name called Wangiri, which is one ring and hang up, or one cut and hang up from Japanese, is that you basically robodial and you do one ring and hang up to maybe 100,000 people. And people see missed call. And on average, 20% of people call back. The kind of classic technique here is to hack a PBX where people haven't changed the password and then just auto-route and auto-forward to your number in Somalia, for example. And then we'll see an example of this in a second. And then either the subscriber or the carrier has to pay the international connection fees. This is a global problem. It's not a problem in other parts of the world. This was the front page of the New York Times around phone hackers dialing and redialing still billions. And they were talking about PBX hacking, and the hackers were using a high-speed computer, and they were cool in that they were able to do hundreds of simultaneous calls. So every minute cost 220 minutes. And there were victims in New York and Albany, and some people lost almost $200,000 in a weekend that they had to pay. And it was the equivalent of 34 years' worth of calls to Gambia, Somalia, and the Maldives. The second kind of dynamic is doing this when you go from your home network to a roaming network, and you exploit the roaming window. So if you're in Canada and you roam to a different country, the carrier in the different country has to tell your home carrier every 4 hours typically what you've done. Now, that means that there's a 4-hour window to exploit loopholes, and if they don't report within 4 hours and fraud occurs, then you can push the responsibility from a fiscal perspective to the remote carrier. So what we're seeing here is people either procuring or stealing a handset, and then going to a remote country or stealing the phone in a remote country, and calling the foreign number and premium rate number. And again, that's the way they monetize traffic to the number, and they're exploiting the kind of weakness of the roaming platform. The other thing we've seen as well, which is kind of a variation on this, when you see these unlimited plans for roaming. So very often what we'd seen was the dynamic around when people roam, they will go to a different country with their phone off, switch it on, make a call, and switch it off because they're worried about roaming fees. So to encourage usage and become the preferred carrier of choice, many people, carriers are having plans with unlimited roaming. And one of the ideas is that you have to pay for, with some of them, for 30 days. But most people will roam for 3 to 5 days. So it seems like a good thing. Whereas a criminal mind will think differently. They can think, oh, there's a $5 a day plan, and I'm not going to just go from my home country, spend 3 days in a remote country, then go home. I'm going to never use it in the home country. I'm going to go to the remote country, and for $5 a day, I have unlimited usage. So we're seeing that kind of variation as well, which is kind of more of a negative margin. The other kind of thing which we've seen really a big rise in is people going into a shop with either a fake identity or a stolen identity, and there's a switch to plan, and basically they'll identify the plans where they don't have to pay up front, and then they'll get a subsidized phone where zero is due today, $31 monthly, and after 30 days they'll never pay. And so they basically got a free phone, and they may abuse the network for 30 days as well. So that's the other kind of characteristic that we believe machine learning is particularly good at doing as well. And finally the other kind of fraud is the high velocity fraud where people attack you, maybe within the 4-hour window. They just go from country to country with new undetected patterns that traditional systems don't detect. And again, that's kind of the known unknowns and unknown unknowns in the Donald Rumsfeld parlance. But again, machine learning is phenomenal at discovering anomalous patterns. We're going to see more about that in a second. So you look at the traditional approach, and in this kind of scenario of attack, people do batch file ingestion, so you often discover the threats too late. They use rules, and rules by definition discover something you've already seen. So if it's a zero-day attack, by definition, rules do not discover those attack methods, and they often generate very, very large numbers of false positives. Also, they work in a siloed environment. So, for example, they can't look across different environments. So, for example, we'll come to it later. If people are going and look in their home network and roam to a different network, you really need to look at them as a whole person across both networks. So, for example, the thing we just mentioned, if somebody's suddenly gone from the US to Mexico and suddenly calls Somalia continually, should you ban them or block them? And it's kind of a more complex question than you think, because if that person is a corporate user that's paid their bill on time for 5 years, extensively used their phone in a very legal way in the US, and then calls Somalia, they're probably doing it for good reason. If they bought a SIM in the US, never used it in the US, and 2 days later are racking up massive bills to Somalia, you probably want to ban them. And so that's what silos can't do. You really need to be able to do that effectively, look at the home usage across voice, data, and look at the billing usage, look at the CRM usage and the roaming usage. And silos just prevent that from happening. The other thing is traditional approaches look at the world as being flat. And they discover an incident, whereas many things occur as a crime ring. So that's where kind of the graph we were discussing comes in. We want to be able to discover whole crime rings rather than incidents. And we want to look at very large amounts of data, because if you're looking for weird patterns, patterns are time-based. So people behave very, like criminals tend to attack on a Friday night at 5 o'clock, between 5 o'clock on a Friday, 9 o'clock on a Monday, on a long weekend on a Thursday, and on a Christmas Day. So you really need to have 13 months worth of data rather than 30 days to really look for anomalous behavior. And again, you need a really low cost architecture to do that. So that was really the crash course around the size of the fraud market, the types of fraud that are growing, the invisible types of fraud, and then what are they? What I'd like to look at now is from the research we did, look at best practice. We kind of looked at best practice not in the mobile sense, but what are people like Facebook and Google doing? There was some kind of interesting stuff that came up, because Facebook has massive scale. And these are stats from years ago. So you looked at, Facebook, you don't get asked on Facebook to put your bank account details in because you won the lottery in Nigeria. They're really, really good at dealing with fraud. So as well as sharing cat photographs, they have a very, very effective way of managing fraud and preventing it from happening. And they've got specific techniques around doing that, and we kind of researched those and kind of modified them specifically for the mobile market. And that kind of approach was to really look at it as there is attack patterns and defense patterns, and they're being attacked by fraudsters, phishers, and spammers. And if you look at the attack pattern, when the attack is happening before it's initially detected, the attacker is in control because the defender doesn't know what they're being attacked by. Then when it's detected initially, you can have a plan to control it. Then when you can detect it, the defender responds and you're in control again. Then the attacker can either have a new attack or mutate an existing attack and begin the attack again. And the whole goal is, what's your approach to this? It's kind of interesting when you look at it from a machine learning perspective, is machine learning in this adversarial sense is different to traditional machine learning, say, on Amazon. On Amazon, your mum will get, she knows she wants to get better book recommendations. And so she cooperates. And she benefits from pattern recognition and supervised machine learning because the recognition gives better results, better recommendations, and she can buy better books. You think about it in this adversarial kind of fraud sense, it's different. The criminal has a fundamental approach to hide and subvert pattern detection and wants to be unseen or disappear in the crowd and really wants to learn the rules. And if there are thresholds, work under the radar and under the thresholds. So specifically, they're going out of their way to just not get detected and abuse the system and fly either under the radar or between the silos. So the approach here really is that the attacks are impossible to stop. The goal is really to shorten their whole attack phase and lengthen when you're out of control, and lengthen the defense phase when you're in control. And the real goal is to make the attack unprofitable and focus on features, and we'll see that how critical they are in a second, that are hard to change or costly to change. So if you look at a really simple example, you don't want to let somebody come on their first day on Facebook and say, you won the lottery, send me your banking account. So you want to stop that. So you think about one of the features you could use to stop that was you don't want people coming in and immediately being able to abuse the system. So you want to have real people with friends. So you could say, people can't send so if your initial approach is to say, nobody can send more than 1,000 messages, then a criminal would say, I'll send 999. So if your first feature is you can only send the number of messages divided by the number of friends must be less than 1. So if you have 1,000 friends, you can send 1,000 messages a day, but no more. Now, that will kind of stop a criminal for a very short period of time because they could buy 1,000 friends. So the second feature you could add is you can only send the number of messages, which is your number of friends, that you've had for more than 6 months. And all of a sudden, a criminal will have to wait 6 months to be able to send the number of messages they need to make a profit. So that feature is just too difficult for the criminal to work around. So focusing on features is critical in this kind of environment. So really what you're really focusing upon is different kind of features. Traditionally, features are there to improve the accuracy of the classifier or accuracy of the book recommendation in this case. What you're really focusing on here is features that are expensive or hard for the attacker to change, to make it either too difficult or too unprofitable. And it's about speed. You really want to have, 2% false positive rates when you detect with an impact 1,000 users versus a better classifier, which is 1%, where your false positives have impacted 100,000 users. So it's really about speed and difficulty of change. The other kind of thing we learned, and has been learned over and over again, is data matters and more features matter. And it's been shown that if you have a small number of features with a complex algorithm, that's not as good as a large number of features exploiting a large amount of data with a simple algorithm. So data wins. There's a very famous paper called The Unreasonable Effectiveness of Data. So given that, how do we apply that to detecting fraud using machine learning in the mobile space? So first thing is you need a data lake, and a data lake is kind of different. So you have very much raw data there. So it's not like if you're looking at subscription fraud from a store, the data lake doesn't contain weekly aggregates. It contains the raw underlying data. So what we really need here, as we mentioned before, if you really are going to look across network usage and subscription usage, you need a combination of domestic network data, roaming data, billing data, and CRM data. Then you can tell the difference between somebody who's been using a phone for 5 years and is roaming, or a brand new user who's never used their SIM at home and is suddenly roaming and and calling Somalia. So the data lake is fundamentally critical. And the other kind of subtle thing is you want to be able to ingest the data across mobile, fixed, VoIP data and BSS systems. Now, as you ingest it in real time, the raw data, you want to be able to featureize it as well. So to give you an example of featureization, for those of you in the mobile space, ISUP is a packet that has call details from the caller, the callee, and the duration. It doesn't really have time between calls. Whereas time between calls is incredibly valuable as a feature for machine learning to detect a Wangiri attack. So as you ingest, what we're doing in real time is real-time featureization and feature enrichment, not just for one or two, but hundreds of features. And that really is critical for machine learning. The next kind of thing which we'll look at is the machine learning going to be supervised? Yeah, fraud, not fraud, or unsupervised. And what does anomaly detection mean? And how could you kind of visualize it as well? And again, when we're looking at what we're going to discuss now is the approach of features are important. And it's about features, features, and features. And it's really around the algorithm you're using is critical, the parameter tuning, the depth of trees, and the learning rate. And those are the things we're going to briefly investigate, really where we can take those concepts from LinkedIn, Facebook, and Google, but apply them specifically to a CSP or communications service provider data lake with machine learning living on top. So the first approach is supervised machine learning, where you look at the world as a complex decision tree, where the bottom node is likely to default, unlikely to default, or certainty of the interval. And you train it on historical delinquency data, and you enrich it into a much larger feature space. So again, features are critical here. The other one is around, which we actually found very interesting. So, because when you have an outcome, people tend to think about you always use supervised machine learning. When the outcome is incredibly sparse, sometimes you're better off using unsupervised machine learning and specifically anomaly detection. And this is the way you can kind of visualize it. So if you think about the XY axis is geography and number of minutes per user. These are typical number of minutes usage here on the peaks, whereas these outliers are kind of outliers. And these are the anomalies that are high risk and potential for fraud. So this is the way you can visualize fraud in kind of 3 dimensions. But if you remember what I said before, we want to have hundreds of features. So how do you do that? So this is what Dayon worked on, and we'll talk about this later. What you're already looking at is whole combinations of features, and you have a log probability of scores. And then it kind of looks like this. And the problem with C is you have too many false positives, but you detect quickly. Problem with B is you miss too much. You have to balance where you're looking at, and A gives you the optimal balance. So that's at a high level, really taking these concepts and applying them to mobile. The devil is in the detail, and this is what makes it work at scale. You need to be able to do high scalability unsupervised machine learning with no assumptions about probability distributions. You need to be able to take categories like A, B, or C, or continuous features. When you're generating the features, you need to have an unconstrained complexity. So the features are phenomenally powerful. So what you want to be able to do is not be limited by the features that you can generate. The other important thing is models decay or need retraining. So you need an approach where you don't have to continually retrain and upload a new model. So we have a non-parametric approach which continually analyzes the data, looking at vast amounts of data for every occurrence, giving you a quantitative score. And we really exploit the scalability of a big data infrastructure to do this non-parametric model. The kind of thing which we'll see very soon in the demo, which is kind of the cool thing in the demo, is around graph for visualization. And what we'll see here is the way to visualize a Wangiri attack pattern. We have one caller calling 100,000 people. These are the victims that have called back in the center circle. These are the ones that have yet to call back. So you can visualize fraud way more easily. It becomes very obvious what it's about. And you can also use graph traversal to do level 1, level 2, and level 3 to see a whole crime ring, which is what we're going to see in a second. So without further ado, I'd like to dive into a live machine learning graph demonstration. To kind of get across some of the concepts, we're going to be able to look at domestic fraud, going to an international number, and with a Wangiri attack. And it's going to come out of Cuba. We're going to do crime ring forensics, and then we're going to look at roaming fraud, where the roaming partner has not met their SLA. So again, this is anonymous data. It's a demo. We have a mythical Brazilian operator, and it's being attacked by Wangiri attacks, in this case from Cuba. and potentially other countries. And we're going to look at that, and we're going to look at a roaming sense. And again, this is all anonymized, but it's kind of real attacks that we've experienced and seen. Just going to flip over to demonstration. So this is a live system, as you can see here. You can look at the live system. Just need to check on VPN. Yep, the VPN is live. Okay, so the whole idea here is what we've been alerted to. We get an alert. I've got two tabs open, you can see at the top, and I've been alerted to this 211 alert. So what alerts really in this case mean is start investigating something's going on. So at a high level, what I want to be able to do is to start investigating, is there something I should drill down on? And I'm being alerted to here. I'm a Brazilian operator. I'm being warned that I've got attacks from Cuba, Peru, Argentina, and Bosnia, and they're attacking my network in Brazil. Now, the core question for me is, what's going on? How big is the velocity of the attack and the volume of the attack, and is it coordinated? So I can instantly go and look at the Wangiri call-in, and I can see that the volume of calls from Cuba, Peru, Argentina, and Bosnia, and I can see that my subscribers are being victims and they're calling back. So I need to go and look at and drill down on the attack pattern. So I'm going to go back to my case management system. I can see this number, and I'm just going to just visualize the graph. And this is going to bring up the visualization that we saw a slide of, and it's just much nicer when you see it live. And what we're going to see here is the Wangiri attack. And this is basic level 1 graph. So what we can see here is we'll zoom out, and we can see here the particular attacker out of Cuba. We'll see in the bottom left, and we can see that these are the victims. Really, blue is a call out and red is a call back. These are the victims that have called back here in the central circle. These are the subscribers that are yet to call back. So really my job is to shut down this attack before the outer circle victims have time to call back. I need to have some intelligence. And I can zoom in, I can zoom out, and if I zoom in, I can see the actual callers have called in and called back. I can even zoom in and see their numbers. So my goal now is this I saw in the high-level graph is a multi-country, multi-international attack going on. Is it coordinated or not? So what I'm going to do now is look at this from a level 3 graph perspective. And we kind of jokingly call this LinkedIn for criminals, is that we saw from the dashboard there are multiple attacks from multiple countries. And the goal here is to know, are these attacks independent or are they operating as a gang? And it's key to know if they're one or the other. So the reason that's important is if they're independent and we shut one down, that's good. If they're working as an organized gang and we shut one down, the other ones just ramp up and take over the slack from the one that's been shut down. So what we're doing here is, as I said, is level 3. And the concept behind level 3 is I may know Dayon. Dayon may know Arshak. Arshak may know Bashir. And that means that I'm from 3 levels related to Bashir. But if I know Dayon, I'm looking at 3 levels for Dayon as well. So it's a recursive descent of the tree going through every node. So what we're seeing is that when every bubble expands, we're looking at 3 levels from that bubble. So there's a massive amount of compute going on here. And when you look at what we're really doing here, it's not kind of 10% better than what you can traditionally do or 10 times better. It's just you couldn't do this before from our experience. What we're starting to see now is the whole attack plan being visualized through level 3 graph visualization. I'm going to zoom out, and instantly what I saw here was that there's another big participant and a third participant. So this is a coordinated international gang attack. I can see here, this one is from Argentina, if I look in the bottom left-hand corner. This is from Peru, if I look in the bottom left-hand corner, and they're all doing vast numbers of calls. So what's interesting, I've gone from a single number in the orange one here to discovering a gang of 3. And people always ask, what are these numbers? And what's interesting when you look at these numbers is, like every good programmer, before you deploy, you test. So if I'm going to do 100,000 calls from Cuba to Peru, I want to test from Cuba to Brazil, I apologize. I want to test against a local Brazilian number, and I can rent these numbers. So this is the rented test number, and this is the rented test number as well. So I've really gone from a single number to people that have called back in the center here, people that are yet to call back, to a gang of 3, and to rented test numbers. So my goal is to really shut this down. Now, the key thing here is I want to be able to shut down these 3 major circles, but not these rented test numbers. I want to store the rented test numbers because if I ever see them used in the future, it's likely they've been rented for an attack. The other kind of missing link here is when I look at here, if I'm really going to attack Brazil, I nearly always have a local accomplice working in Brazil. So the problem is who, out of all the numbers that have been called, is working with this person in Brazil. So when I focus in and zone in on the orange circle, he's called hundreds of people with the Wangiri attack once. He's called a number of people with the Wangiri attack twice, and we zoom in here. But if you look at the number of calls, make it 3, suddenly we can see the local accomplice. So if we zoom in, so this is the local person in Brazil that he's had conversations with, which is how he's going to monetize the money. So what I'm going to do now is, obviously this is one of the players. I can do a couple of things. I can blacklist this person. But I can also just, if I finally want to do some final validation about are they performing criminal activity or not, I can even look at their call pattern as a time series. So I can see here, this is incredibly suspicious. Nothing, big scale attack. So again, this is definitely criminal activity. So that's really looking at the domestic attack pattern that's multinational, going from a single attacker to a gang of 3 to test numbers to a local accomplice, being able to blacklist and look at it as a time series, all within minutes by using the power of graph and machine learning to reduce the number of alerts that I'm getting. What I want to look at now is the same thing in the context of a roaming attack. So again, we'll go back, and here we'll put the case. I'm going to sort the time of the fraud. And there's some suspicious behavior here. There's these kind of sequential blocks of numbers. So I want to go again, it's really alerting me to go and take a look at the graph. So what I'm going to look at now is the roaming fraud. And again, I'm a Brazilian operator, and there are people roaming in Colombia, and they're making a large number of calls to Somalia, and the Somalia in Latvia. But I'm not focusing on this. What's interesting is they're in Colombia, and I want to quickly look at how consistently good is the Colombian operator I'm looking at. And again, this is anonymous data. Because what's interesting here is if there's a 4-hour SLA, I should see nothing in 5 hours or more. And these are called TD35 files. They're batch files that come every 4 hours that say what my Brazilian subscribers are doing in a remote country. And I can instantly see that sometimes and periodically they're out of SLA. And what's interesting is if the fraud is in here, in under 4 hours, it's my problem. If I can prove very simply it's over 4 hours, sorry, then the fiscal responsibility I can push out. So what I can see here is that there is an issue around people in Colombia calling Somalia. And it's very suspicious as a block, 10, 11, 12, 13, 14, 15, 16 numbers. So what I will take is a concept of a data lake and look at these numbers. And I can view the calls from this customer. So what I can see here is this is what's called conference. It's a variation on RSF, calling it conference numbers. They're doing a few things. They're basically making a phone call, putting on pause, making a phone call, putting on pause, making a phone call, putting on pause. And they're calling Somalia. They're calling a range of numbers, 10, 11, 12, 13, 14, 15, 16. They're calling before people start working at 9 a.m. And the other thing is they know our rule. We have a basic rule that's over an hour is suspicious. So doing lots of calls under an hour. So this is definitely an organized attack going on. If I go back and look at the B number again, just to get more details, and I look at it here, what I'm going to look at here is I want to look up the customer. And I can see that they've had 2 days of service, and they've never used it locally. So again, I can instantly get to this kind of gang. And what I want to look at it is from a different perspective as well. I want to look at it from a graph perspective. So I'm definitely suspicious here. So here are these numbers. And I'm just going to look at it now. I'm going to look at the number 14 out of the range. And visualize it and just show the power of graph. Because it just shows you fraud in a different way. So this is kind of boring. So I'm just going to take this simple conference call attack pattern and look at it from a level 2 perspective. And suddenly it changes the whole way we can look at it. So there's the level 1. We're just doing the recursive descent to level 2. And you can suddenly see everybody's calling this conference number. 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 So this is a coordinated attack with the greens. All these conference numbers that are being called, and so is the blue. And then the oranges are the gang that are already either stealing phones or procuring them. And they're just racking up as many minutes in as short a period of time as possible and trying to go undetected using techniques like under an hour. So then all I have to do is just, I can highlight the blue. I can drag it around if I want to. I can highlight the green. And I'll just blacklist it. So I can just blacklist it like I did previously. Again. So again, what I'll be able to do here very quickly is, in a simple sense, be able to look at a block of numbers, find the conference numbers in Somalia, and identify that the gang's attacking it. And just to wrap up, what would be really nice is it my fiscal responsibility or not? So what I'm going to do is just wrap up the demo now by looking at the power of a data lake. So these B numbers, here, these are all fraud. I've kind of validated that they're fraud. Wouldn't it be great if I could, across the data lake, look at the combine this data with the TD35 delivery data. I'm going to make this 4 hours. And what it's done now is blended the roaming data with the fraud data, with the TD35 SLA data. And what we're going to and then the roaming fraud with the SLA revenue clawback. We did that in this kind of sense. So just to wrap up, when we look at the kind of the big data approach, we're really shifting towards real-time raw data and to do real-time either anomaly detection or, in the case of subscription fraud, machine learning from a supervised sense, and really exploiting the power of a data lake in what we call Crime 360, and using graph-based visual analytics to discover not individual attempts at crime, but whole crime rings. And it's written natively in Hadoop to exploit the power and raw compute capacity of Hadoop. So in summary, I think, what's important is we're all going to be using machine learning, either today or in a few years, in many aspects of our lives. And most people don't know how to use it. So we won't know and we won't care about the fact that it's there underneath. We'll just notice things getting better in things like voice recognition, facial recognition, self-driving cars, and fraud detection. And the core thing is, from a couple of perspectives, the focus is to make the attack unprofitable and to focus upon machine learning features that are hard or costly to change. But equally as important, we want to make it simple for everybody in the organization to use. So any fraud analyst can use really sophisticated machine learning without having a PhD in data science. Just like people used Siebel to do CRM and PeopleSoft to do a HR without learning SQL. That's what we believe will be important, is making machine learning for everybody so everybody can benefit from it. So as Bashir said, we wrote a book about this, and it's called Fighting Future Fraud, Strategy for Using Big Data, Machine Learning and Data Lakes to Fight Mobile Communications Fraud. And then there's a second one which looks at in detail the fraud and revenue threat analytics, the bigger picture, really looking at that's where we drew some of the statistics around the trends within fraud. And there's a couple of websites around Fraud Tech Wire where we try and have the most relevant news every week around fraud and big data. And the book can also be downloaded from argyledata.com. So as I mentioned, the The guy who wrote a lot of this, Dayon, is with me, and he's got an appropriately difficult to pronounce surname for a data scientist. And we're open now for Q&A. And again, the book's available at fraudtechwire.argyledata.com, and that's our Twitter handle. And Dayon is on to take any questions with me as well. So we're opening the floor to questions. Hope that was interesting.
Yeah, it was very interesting. People who are on the web, hopefully you got some questions you would like to ask. Let me make sure that you're not muted so that we can actually, you got a couple of ways you can even put your question through the message at the bottom, if that's how you want to ask. I'm looking out to see if somebody's, or you can put your hand up and I'll unmute you. I can unmute anybody who wants to ask a question. Another way you can ask is click down the chat area and type your question in there if that works better for you. Don't feel shy. Please ask a question.
So one question I'll ask Dayon, which we often get asked, is around, are we using MapReduce in batch, or how do we do it in real time? So you got any comments on that, Dayon?
No, we are doing the basically real time, or I would call it near real time. Meaning near real time is basically as soon as the call happens, we analyze your patterns. So basically it's a I would say real-time approach, so no batch processing in this case. The main benefit of our approach is basically the time.
Muted.
I think people got muted here. 1 second.
Unmuted.
I think you may be muted. Do you want to answer that question?
Dion, can you please repeat the part you just talked about? I think you got muted there.
No problem. Please. So the yes, we are a real time, or I would say near real time fraud detection. Why is near real time? Because we need to collect enough data about you. So, but we are doing the analysis in a scale. As soon the call happens, we go to our data lake, collect all the your history, patterns, who you are, what you do.
It's hard to understand, Mark.
Hello?
Keep going, Dayon.
Are you there? Yeah, go ahead. I think
so basically that's our approach, and our key advantage over the competitors, or at least batch processing, is this quickness of finding the fraud. So if our time is matter of hour, half an hour, depends basically on the activity, versus your batch processing what you do at the end of the day or end of the week or the month. So there is a huge savings in the whole process. So yes, we are real time in the whole process.
So the other question, Dayon, I know we often get asked, is about, do you have to kind of have a new model regularly? So how do we go about continually updating the model as opposed to having a champion challenger model where you have a champion and then the challenger until it gets better? So what can you just discuss that?
Well, we are basically periodically updating our models. So basically, we have the all user activity and everything. So you periodically update the model and see how things are going. So basically, there is no, it's a bad idea to use the same model for years. So you need to keep up with the trends.
That's called non-parametric, isn't it?
Absolutely, yeah. The non-parametric model, basically, that's the very important feature is like we don't assume any distribution or anything. We put the featureized data in our model, do some training on it, and then, you know, basically that's it. You know, that's the model for the day.
So for both of you, there are quite a few questions that are popped up that I can see. So I'm going to ask one at a time. As the first one says, can we access the lecture and the book that has been mentioned? The lecture you will be able to access because we are recording it. The book, I think that Ian mentioned that you can go to the www.argyledata.com and you can download. Is that correct, Ian?
So there's a couple of ways you can get the books. The Finding Future Fraud is on our website, which is available on argyledata.com or fraudtechwire.com. There's a brand new book which is not published on the website yet, and if you go to tom.howells, that's tom.howells at argyledata.com, he can email it out to everybody that's been on this webinar or attends the recording. Again, that's tom, as in Tom, .howells, Howells, at argyledata.com, and he can email the new book, which looks at the statistics and analysis around the fraud market.
Fantastic. If anybody has missed that, we will include it in the follow-up with each of you. So you will get that. You can go there, and he'll send it to you. So that was hopefully the first question answered. The second question is talking about, can you explain feature?
I'll do it at a high level, and Deon can do the detail. So a feature, when you think about if you have 5 columns in a database, a feature is an extra column. So if we think about specifically around call packets coming in, I have a caller, callee, and a duration of 3 columns. I think it was 3 columns. But I want to add in a useful 4th feature, which is time between calls. So a feature is an incremental column I add when I'm ingesting the data. That is particularly suitable for feeding into machine learning. And the key thing here is you may ingest 3 or more columns and add in 100 features. So you heavily featureize the data, and that's what feeds the power of machine learning. The feature can be individual values, or can be aggregate values as well, like loop values. Deon, have you got anything to add to that?
I'm afraid for my job, you know, that you did a very good explanation.
So that was good explanation, very good.
And again, you look at the data sets, I think that part of the secret is very, very heavy featureization and understanding the features and generating them in real time.
Fantastic. We have another question here that says, can your mobile work for all devices, meaning this models, for Android and iOS, meaning Apple, I guess? Could you walk us through the process to create the model?
So absolutely. So what we're looking at is call packets. So basically, let's maybe go back a slide here. Might be able to go back.
And I think they're also asking for best practices or methodology.
Yep, so I'm just going back to the data here. Here. So what we have here, we basically ingest the data, and we ingest call packets or roaming packets, or so it's almost independent of the underlying device. We're basically looking at the network traffic. So absolutely, we can do Android and iOS as well. Got anything to add to that, Deon?
No. Basically, we are looking to traffic. It's independent of device, so it's famously called metadata, right? And
we do. I think the other thing is we blend it with other data, so you get, instead of looking at just one siloed view, the whole concept of a data lake, because you look across different silos to get a unique kind of view, and the machine learning can work across data that's spread across many silos. And that's what gives you this kind of unique insight into what's happening across the network rather than within a silo.
Correct. The key, one of the very important features is this, your billing data, basically. You're paying your bills regularly, historical data, who you called, last month, this month, and so on.
So yeah, so that's really the concept of a data lake. And again, what you're doing is bringing in the data from the various silos and adding in features in real time. I'm just, the other example, one of the previous question was what is a feature? We think about the Facebook example I gave around a limit on the number of messages you can send per day. If that's 1,000, somebody could do 999. So I can now add in a feature, which is the number of friends you've got. And then I can add another feature, which is the number of friends you had for over 6 months. Those are examples of features which we add in real time. And then we use those to determine whether you can send out messages or not. So that's an example of the concept of a data lake with features.
Yes, and it's for this machine learning is, as I add all these features, it's like your signature and how strange user you are, how strange your signature is. So if you
I think that's a great point, Dayon. So the better the feature set, the better the set of features, the harder it is to not look weird. So what we're looking for is anomalous behavior. And with the appropriate set of features, it's very difficult to hide under the radar and not look strange. And from a behavior or fraudulent behavior perspective, and so you're kind of either detecting them or making behave in a way which is unprofitable for the thief or the state actor.
That's the key. What I just want to reiterate that's the key. Having a lot of features, because if I look you just one way, you can satisfy one rule. But if I put many of these, it's basically very difficult to hide. And if you're able to hide, basically, then you're not profitable. You cannot, do any damage. So if you cannot do any damage, well, job done already on our side.
That's very good, actually. Yeah. So here's another question that says, how do you suspect suspicious calls, I guess? How do you how do you catch suspicious calls?
The key is in this, your signature and comparing you to the others. So exactly the picture it says. So you have this lot of features and how unique you are among the other people. The key to know here is that the fraud in the telecom industry is very rare event. So if you are having a strange signature, probably you are a fraudster. I'm not saying that you are, but most probable. And then, of course, some human intervention, it's needed, to take a little bit more around and make that decision. But key is how strange you are comparing to the others.
So when you look at things, the beautiful thing around big data is strange anomalous behavior sticks out more. So when we're looking at massive data sets, these outliers are anomalous and very likely to be fraud, whereas these are almost certainly unlikely because everybody's behaving in that way. And when you look at it logarithmically, it kind of goes down from a peak very quickly.
Yes, yes. So one more time, key is fraudsters are rare. Most of people are actually using responsibly the network. And yeah, so if you find these people who are really outliers, something is strange and possible. Fraud is very possible.
It's the features that are allowing you to make sure that you start to see the outliers easily, correct?
Exactly, yes.
And the generation of the features in real time, there's no point having features where you discover the fraud after 30 days or one day. So it's the real-time featurization and the real-time machine learning detection is key.
Yes.
Here's an interesting question. How much, what is the cost and time to have a machine learning set up in an organization?
We have a pricing model based on number of subscribers. So the more subscribers you have, the more cost it is. So we have to discuss it with that person around the number of subscribers they have.
The more an individual.
Obviously, the more subscribers you have, the bigger cluster that you'd have as well.
Okay, and also, I guess, makes it more effective, right? More.
The more data you have, and the more features you have, the more effective things are. Yeah, absolutely.
Okay, so that answers that question. What about what computing power do you need?
It's a great question. So we use blades, cheap blades that run with Hadoop. So it's really low cost commodity hardware. It's designed basically the recommended blades we use are what Cloudera recommends. So it's designed we can start with, I think our minimum configuration will be like a small 5-node cluster, but we can run to very large clusters as well. But each node within the cluster is a typical Cloudera Hadoop node.
Okay. The next question then is, how popular is Bayesian network in the area of ML?
Deon?
We don't use this in our approach, so yeah, I cannot answer if anybody else.
That's fair enough.
That's quite an old approach, isn't it, already, Deon?
Yeah.
Okay, I guess it's...
I think that's a very interesting question, is you look at computing and sometimes it moves slowly, sometimes it moves quickly. And we actually spoke to an operator and they said, oh, we looked at machine learning 2 years ago. Well, the truth of the matter is machine learning has evolved dramatically in the last 2 years across many, many different fields. So in fraud, it's evolved dramatically. But there was I think it was a Google competition for image recognition, and it went from... Do you remember that, the New York competition day where basically the recognition rate went through the roof on the GPUs in 1 year? So progress in 1 year was just massive. So if you look at machine learning as a field, it's evolving incredibly quickly. So what was new 3 years ago is kind of old now. Darren, do you remember more detail?
That's correct. And key thing is your methods there are new methods, but there are also, you can use old methods, but now you have much more powerful machines. So things which were impossible to do a couple of years ago now are possible. So, as technology, meaning both things are changing, the hardware and the software and the art of machine learning. So, if something was impossible 3 years ago, you shouldn't, take this result today.
Yeah. Here's another question. I don't know whether it's cut off, but is the fraud specifically for detecting billings? I don't know if you would have... Go ahead.
I think there are many types of fraud. There's fraud on a domestic platform, fraud on a roaming platform when somebody else is. There is subscription fraud. So, and there is, and when you're committing fraud, you can either commit network abuse, or you can never pay for a phone, or you can commit premium international revenue share fraud. So it's for all of these types of fraud. So if we look back at the original market for the fraud of being 38 billion, there are many different types of fraud. And we discover network-based fraud, the domestic or roaming, and subscription-based fraud, dealer-based fraud. Those are kind of the big 80-20 rules that we discover.
Okay. We have yet another question which says, is your model useful for telecom industry only? I would have to say that's not necessarily true. You've talked about that, but it could be used in whatever business that you wanted it to be used for, correct?
I think the truthful answer to that is it could be used in other industries. We don't have any experience there. So we've got massive amounts of experience in the mobile telco space. So we believe we understand this domain and this problem in massive depth, whereas we don't in financial services, for example. So we believe our experience could be transported into other areas. We just don't have the expertise there and experience yet. Whereas we have a massive amount of experience in telco.
I would agree. You have a general methodology, but for any ML to work, you need to have a data, right? Basically historical data, and to analyze and train your models and say what's normal, what's not normal, and anomaly detection. So yes, our general knowledge is definitely transferable to any industry, but there are specifics. You need to learn the industry, and what Ian was saying, the key to machine learning is features. And features are coming from your knowledge about the industry. We are not putting just raw data in the system and say, okay, tell me what's wrong. So you need to understand what's going on there, create those features, and then your machine learning algorithms are going to do good results.
Dan always laughs when people say, give me the data and I'll run it through my algorithm and tell you everything. That's not true. Dan always smiles when he hears people say that.
No, that doesn't work. I have to agree with you, because like in the credit card business, behavior pattern for us was critical as to exactly as what you said in terms of phone usage, as to how somebody actually used their credit card, meaning they're buying gas at this days, restaurants, where they go, travel, which days, approximately how much. Similarly to what you're talking about, who's phoning whom, when approximately, and suddenly you see a completely out of pattern behavior. So you're right. You need to understand that business, and therefore the data then becomes very helpful once you know generally what the business is, right, or what should be normal, right?
As a British phrase, jack of all trades and master of none. It's much better to be master of one. Yeah.
I totally agree with you. There are people who are saying there's a great session, found it very helpful, and will they get, yes, we're recording and we will definitely make it available for people who attended here today. What is the next question? What industries are currently using data lakes to combat fraud? I think that a lot of industries are using. Ian just talked about the telecom, but the data lakes and that approach is not restricted to telecom. Is that correct, Ian? Would you agree with that?
Well, you did some great work in financial services yourself, Bashir. So, we see it being used in particularly in financial services, in mobile communications, in e-commerce. I think that the big analogy I'd say is, you can see I've got grey hair on the side of my head from this picture. As you think about the 80s, was about a better way to manage data, and then there were many applications on top of Oracle in the 90s. So just Hadoop is basically become just an accepted better way of managing large amounts of data. So there'll be many applications across many industries, and I think it will impact horizontal industries like CRM with the Salesforce Binary Relate IQ, for example. It will be across different verticals like finance and telco. So I think it will permeate most applications that are horizontal like CRM or HR and most verticals. It's just a matter of time. By the end of the 90s, relational had permeated nearly every industry.
Actually, that's true. I totally agree. And it continues to do more and more. Here's another interesting question is what is the size of the data lake used in this example that you did today? And what is the size of the infrastructure used for hosting the solution?
Great question. So again, the data lake depends upon the number of subscribers and the amount of data going in, and then how long you want to store the data for. So it depends upon the ingestion, the sources, the ingestion rate per source, and then the duration. And you can start with a small 5-node cluster and go up to hundreds of nodes, or certain people want to be able to run on Amazon in a virtual private cloud as well. Within the country of residence. So again, both are applicable. It just varies by the number. It's like
the beauty of this Hadoop infrastructure is it's like you can grow as you have more data, add more nodes in a cluster, and the things can be processed. So of course nothing can grow infinitely, but it scales very well.
You say can't grow infinitely. It's big enough for every telco in the world.
Absolutely, that's for sure.
And it's key that the data is in one place or accessible, I guess is probably the right word, because we've got a lot of organizations that I've seen where the data is so uniquely broken up into different mainframes and restricted to that area that it defeats the type of thing you want to do unless it's accessible in a data lake so you can get that. Would that be a safe statement to make?
It's a safe statement, and there's a nice subtlety around it as well. Is that we're not importing. We import some billing and CRM data, but the other data is the raw live new data coming in. It's not like we have to go to 25 different systems and aggregate the data and cleanse it and ETL it, and we're just importing the raw packet data in that's new. So it's not like it's a big integration problem. Our integration is into the new packet data that's coming in and blending that with some billing and CRM data. It's not about integrating 50 different IT systems.
Okay, that makes a lot of sense. There's another question here that says, what other types of fraud are there, I guess, besides, hang on one second, besides the international revenue share that you just talked about?
So the way I think about fraud is that there are two things. There's, if we go back, the methods and types. So there's a way to approach it. Just bringing back one. So we think about a premium rate number in America. I can set that up, but if nobody calls, I'll make no money. So that's a type of way to make money, and then there are methods to drive traffic there. The method can be hacking a PBX and auto-forwarding the calls. The method can be a Wangiri. The method can be, you may laugh at this, but there was organised crime doing this in London, in an organised way, stealing phones from ladies' handbags and calling Somalia. Premium rate number. So basically you have a type, which is a way to generate money, and then there are various methods that you can use to drive traffic to that. And then you use various combinations of it as well. So here's some examples. There's premium rate fraud, international revenue share fraud, arbitrage fraud, domestic fraud, commissions fraud, wholesale fraud, interconnect bypass fraud. There are many, many, many different types. Our approach is to look at what's the 80-20 rule, and it's really ways to drive artificial inflation of traffic with the IRS, FDRS, or premium rate, or then subscription fraud, which is around either stealing phones or commissions fraud. Those are the big current ones. And then I really believe, the other kind of key thing is, if fraud's gone down from 46 to 38, but 73% of people believe it's the same or going up, what's happened to that 8 billion drop? Is it suddenly invisible?
Yeah, that's a very good question.
So I think invisible fraud is a major category.
In some companies, they would rather not admit that they had fraud and do write-offs in a different way, right?
Yeah, that's bad debt on the books.
Correct. I've seen that happen certainly in the credit card business. It's happened where they don't admit it was a fraud. They write it off as bad debts, and so the guys don't look bad. Here's an interesting question, which is, what software did you use to create the graphs?
That's a great question, and Dion actually wrote it. So that looked a really slick, pretty demo. That was really hard because most graph stuff is horribly slow. So you won't see many people demo graph because you get responses in hours, and that was a pretty quick, even though it took a minute. So Dion wrote it. We wrote our own kind of graph to get that kind of response time.
Well, we have a UI team, I'm sorry. I think they use D3 JavaScript. That's just for the presentational layer. And then there is this data collection layer that's our database we are collecting. We are using the, so that's.
You've been very modest, Dale.
Yeah.
Seriously, that kind of performance transforms it from being a batch process to a pretty interactive process. And fraud is incredibly visual, but if you use it this way, you can train people to see certain patterns very, very easily. For example, the Wangiri pattern, the crime ring pattern, the conference call slamming pattern as well.
Interesting. There is, by the way, a question that I missed earlier on, which says, besides the data, as you have mentioned, what about the prior knowledge incorporated or in the processing? I think you did talk about it briefly, but...
Absolutely. I think, again, that's a very good question. You look at the DNA of the company, we have a blend of people who are experts in machine learning, big data, and the mobile fraud space, the mobile space. So it's a combination of that, as Dion says. We get the right features for mobile. We probably don't know what they need in financial services. So that's kind of the blend of people that allows us to do this.
Do you find that when doing this thing, interviewing some of the people in the company to understand some of the challenges they've had, at least in terms of some of the norms, that it's helpful?
Absolutely. We interviewed a large number of people out of the fraud space, the financial space, the security space. And then really kind of part of what we're really doing here is bringing together the big data people with the fraud people, because there's a new platform that needs apps, and there's people that need better apps. So I think it's part of it is bringing an organization together. There's a new Hadoop platform with a data lake underneath it, and there are new apps that are going to come on top. And I think fraud is one of the best apps to initially put on there, and that we typically see that in customer churn. But fraud is a really good application because once you've got that detail in there, it's very applicable for subsequent applications as well. So we've interviewed people from both the fraud side, the security side, and then the big data side as well.
And once you have that under control, it also helps the marketing because you have the behavior pattern of the person if you want to target them for sales, right?
Absolutely. So I think one of the early slides is, I think the critical thing around a data lake is to think about having one data lake, not a data lake per application, for two reasons. You add in incremental data around the customer and you can start doing a different kind of customer 360. And then for the Internet of Things, which everybody's talking about, is when there's a SIM in every car and you've got things where you've lost your keys or you can't remember where you parked your car, it's not economically feasible to have a new infrastructure just for these small applications. They need to sit in the existing infrastructure and blend with the existing data about the existing customers who also have phones as well as SIMs as well as keys. So I think that's one of the important things. And then you're plugging into an existing infrastructure, so new applications are much lower cost.
So when you look at
the data lake expansion strategy.
Okay. So when you look at the current mobile and some of the big data stuff that we witness, would you agree then that we, based on what you just said, that we are moving away from application-centric to data-centric?
That's a great question because when you look at the applications, they're still applications, but a lot of the work is done in the data. So you have, right. I don't know how to explain it properly, but the applications are much thinner, and a lot of the knowledge is in the data science part in the data-centric applications.
So more data accessible or in one place it makes this results far more effective.
Absolutely. So moving from silos to a data lake allows you to get new kind of insights, and the analytic machine learning insights feeding to applications. So I think we're going to get many thinner applications across one data lake, and it'll be much easier to introduce new applications once the data's there and the machine learning layer is there as well.
It would be safe then to say that really, based on that, there could be a significant amount of operational efficiency can be identified in here as well.
Absolutely.
Right. Well, I have run out of questions, and I think the people on the, unless there's anything else, and
there's certain things you can't see that are going on. Whereas when you have a data lake, you can easily see they didn't see them before. It's because it wasn't possible to go across multiple different silos. Whereas when it's all in one place, it becomes relatively easy.
Yeah, absolutely. In fact, Ian, one of the things that as you were talking about, I realized that there's a lot of duplication, especially in large organizations. They may not even realize. This could identify that because you then even tighten the security because you go to many points of exposures that can be shut down, not only the fact that you shut down the costs for not duplicating the work. Because if you look at large organizations, I've come across stuff that's done in 2 or 3 places and people didn't even realize that 2 different people were doing it.
Absolutely. So it's maybe not a great example, but it kind of gets the point across. Imagine if every store had their own database, and then somebody went in and basically got a subsidized phone in every store. If every store has their own database, there's no way you can discover this person's gone to 50 stores. If you have a data lake, it becomes obvious after the second attempt. That's right. That's kind of a simple example of what a data lake can do.
No,
so
that's
it makes things that are previously really hard to do just because of the operational infrastructure much simpler to do.
That's fantastic. Are there any other questions, folks on the web? You've asked some very good questions, and hopefully Ian's answered and Diane has answered for you. And it's all recorded, so in case you forget, it'll be there in your stuff that you will get. So I don't know, any other points you guys want to add? Because I think you've done an outstanding job in covering this subject very, very well and answer the questions very well as well. So one more go, guys. Any questions? Not that I can tell you. For those who didn't realize, Ian and Diane are actually in San Francisco Of course, I'm here in Toronto, as a lot of you are, and some might be across the country, but which is why we had to do it this way. But I think it's been very effective, and Ian and Dan, thank you very much for making this time available to actually not only present, very educational and informative, but also answer the questions. And if anybody wants to follow up, and you'll have all the contact information, and if your company is certainly interested, all that can be done. And I want to thank each and every one of you who took time and trouble to participate in this, and I hope you found it very useful. So what we're going to do is wish each of you a wonderful evening. Those who are at home, fantastic. If you're driving back, drive carefully, and look forward to talking to you again soon with another interesting topic that will be helpful. So Ian, once again, and Dan, thank you very much for a fantastic, presentation.
And thank you very much for arranging this as well, Bashir.
Thank you, Bashir. It was a pleasure talking to you.
Absolutely, my pleasure as well. Thanks, guys. Have a wonderful evening, and we'll chat later, Ian.
Cheers. Thank you, everybody.